condition for which we would be able to make use of sine law in solving oblique triangles is that you have two sides and one of the sides is opposite that angle. I told you before that using sine law is making sure that you have at least two angles in the triangle, but this one you only have one angle, but the angle is opposite that side, so we can make use of sine law. So the first thing we do is to find another angle, and of course it has to be this angle because you have an angle here, but the side opposite that angle is not known, so it must be this angle that we have to solve. So first thing we do is to name our triangle. So let's make use of DEF this time. Okay, so this one now is side D, this is F, and this is E. So obviously, we cannot make use of E as basis of identifying the formula we will be using for sine law. So we will make use of F. So let's say I will start with F over sine F is equal to D over sine D. Again, you can actually reverse or reciprocate your formula. It doesn't matter. Okay, now what we're trying to solve here is sine F. So I usually give it like a sign that it's the one I'm solving. Now remember, sine and F are always together. Okay, so you cannot separate them. So they're just expressed as a single expression. So what we can do is to substitute F, that's 20, over sine F is equal to 25 over sine 25. So again, this is not known. We are trying to solve it. Now we can cross multiply. So I'll make it here so that you can see that's 20 sine 25 is equal to 25 sine F. Now because we're solving sine F, we will divide 25. So therefore, 20 sine 25 over 25 is equal to sine F. Now, because we're solving an angle, we have to make use of the inverse functions. Therefore, our F, or we can name it as measure of angle F, is equal to second sine of this value, 20 sine 25 all over 25. So to do that in the calculator, so you have second sine, because we're finding an angle, so you have 20 sine 25, close it, divided by 25. And that would be our angle. It's equivalent to 19.76 degrees.